Okay, your assessment is coming up. The way that I work is after the teaching is done, where it will be finished today, you'll get a practice test and you've got a full week between now and next Friday. Next Friday is when you're going to get your test on the 3 things that we've learned up till this time. Okay? I will help you out. I've got an example cheat sheet that I've written. And for you guys, because it's the first time that you're getting tested with me, you'll be allowed to write your cheat sheet on the back of my example one. Does that make sense? Right? Whereas before, you might have had to write it completely from scratch. I don't know what they did before, but I'm trying to catch up what has been done in the past. So today's lesson is about something called scientific notation, right? Currently, when you write numbers, you write them in decimal form. So what does that mean? It's a bunch of digits to the left of a decimal point and a bunch of digits to the right. So 6.75. Can you actually tell me what 6.75 means? The 6 means what? 6 tens? 6 ones? What does it mean? 6 ones. So the 6 means 6 ones. What does the 7 mean in 6.75? Is that still 6 ones? What column is it in? Hopefully you did that in primary school. Yeah? Tenths. Because hopefully in primary school you've seen something like this. You were given like a T shape and you said units, tens, hundreds, thousands. And this was tenths and hundredths, etc. You don't need to copy anything down just yet. This is me just reminding you of what has happened in the past. So 7 tenths. What's the 5 mean? Someone other than Isaac must have gone to school before now. What column is the 5 in 6.75? Hundreds. Well done. Hundreds. 5 hundredths. Do you agree that for a number small like that, 6.75, is that reasonable to write it that way? That didn't take long. I'm just writing 3 numbers and a dot. The problem with decimal notation is when you're writing extremely large or extremely small numbers. It's a waste of time and space. 325 decillion is this crazy thing. Would you like to write that in a test situation? What if you missed a 0? You're completely wrong. This 62 quadrillionths is an extremely small number. Would you like to have to write that in a test? Would you get it completely wrong if you missed a 0? So what you can see is there's a lot of zeros taking up space, either at the start here, can you see that's at the start of the numbers, or zeros at the end. These zeros that sit right beside each other with no numbers between them, they're called placeholder zeros. Can you copy that first thing in blue down? That's the first main point that you need to get down. Any zeros that are just pushing the numbers one direction or another is called a placeholder zero, yeah? Do you need a book or something? Or do you have a question? Oh, sorry, big finger can't see. These zeros that sit right beside each other and have no numbers between them, they're called placeholder zeros. So that 325 decillion, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 24, 25, 26, 27, 28, 29, 30. 33 zeros, and all it's doing is pushing 325 all the way to the left. Those are called placeholder zeros. Can you just bring the box over so you can't stand in people's way? Bring the box. Just a reminder, I've given you a box to store your books in class, and you could just take them home like the people that do their homework. If you lose it, that's not on me anymore, yeah? Okay, what you are going to be practicing today. This is the last bit of learning that you have to be able to do out of 3 things that we've done this term is writing things in scientific notation. So this big thing here fully explains scientific notation. Scientific notation is a shortcut for writing this. I don't want to write 33 zeros and miss one and stuff it up. I don't want to write all these zeros, miss one and stuff it up. I need a shortcut to write it. So a number in scientific notation looks like this. You've got a number, I don't know what it is, A, and then you've got times by 10 to the power of something else, which we don't know what it is. So can you get that first box down? A times by 10 to the power of n, and then I will explain what A and n are. Then I'll show you 3 examples of how do you do that, and then you can practice. You'll have all of next week for practicing 2, then Friday, test time. So scientific notation, A, times by 10. It's always times by 10 to the power of something. What is A going to be? A has to be a number between 1 and 10. Has to be a number between 1 and 10, and it represents all the numbers that aren't your placeholder zeros. So in this giant thing here, this one that I've circled here, 325 and 33 zeros, what are the numbers that aren't placeholder zeros in this? 3, 2, and 5. Good. Is 325 a number between 1 and 10? Is 32.5 a number between 1 and 10? Would 3.25 be a number between 1 and 10? Good. So that's what A would be if I wanted to write that in scientific notation. Now you need to understand what n is. N is a power of 10 that jumps the decimal point right or left in your A to match the number that you want. If n is positive, the decimal jumps right. If n is negative, decimal jumps left. Get that down for now. That's not going to make any sense right now until I show you how it works. So just trust. Is that what kids these days say? Some of my year 10s saying trust or something. Trust that I'll do the homework, and then I see that I didn't do the bloody homework. Trust it, and then I'll show you how it works. So get that second bit down, explaining what n is. I'll scroll it up to there. You have a question about the writing? I'm not sensitive about it. What's the question? N is a power of 10 to jump the decimal point right or left in A to match the number you want. Right now, you'll be like, what the hell is he talking about? When we see an example, you'll see what the hell I'm talking about. Okay, I'm going to leave that big blue thing up there so we can see the rules while we do an example. Okay? That purple stuff there, that is just for me to help you follow along in the thinking. As you practice, you won't need to write that. Okay? But right now, I want to do it laboriously. I want to write 325 decillion in scientific notation. This is the number I want. I want 325 and 33 freaky zeros there. Our student over here told me, what are the non-placeholder numbers? What are the numbers that aren't zeros all right next to each other? Can you repeat, please? What was the numbers that aren't placeholders here? 3, 2, 5. So that's my thinking. What are the non-placeholder numbers? 3, 2, 5. What number between 1 and 10 is going to represent 3, 2, 5? It's not going to be 325. It's not going to be 32.5. What was it that... 3.25. I know my A now. You're going to get part marks for this already. If you just get 3.25, you got half your marks. But this is the tricky part. I told you, trust. What the hell does that mean? Let me show you. How many jumps and what direction to get the decimal point to match? You just decided that your number is 3.25. So where is the decimal point between? What two numbers is the decimal point in the middle of in 3.25? 3 and 2. So imagine the decimal point right now is between your 3 and 2 in that giantly long number. In that giantly long number here, where actually is the decimal point? It's all the way here. See how they're not in the same place? I want to represent it with a number that's got the decimal point between 3 and 2, but the decimal point in my actual number is all the way over here because it's a whole number. So what could I do to work out how many jumps? I literally draw the jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. How many jumps did it take to get the decimal point places matching? Where did I just count? 35. What direction did it jump? Right. So according to this, what sign should n be? Should it be negative or should it be positive? It should be positive. So how many jumps in what direction? 35. Right. So what am I going to write for scientific notation? Your answer is going to be this. 3.25 times by 10 to the power of, how many jumps did I do?
35.
And what direction was it?
Right.
So should it be negative 35 or positive 35? 35. Get that. Get down what you need from that. The video will be up showing you that process, but I like you trying to get it. Does anyone here have a fantastic 100% photographic memory? Yes or no? No? Yes, because if you had one, you'd be rich. You wouldn't be here. Huh? In what way?
Not everyone who has photographic memory actually uses that photographic memory.
Okay. Well, that's a shame. What I'll do is I'll scroll it up here. If anyone does have example 1 fully down, start thinking about what our answer would be for example 2. Think about what's the non-placeholder numbers in example 2. Oh no, Isaac knows. So look, example 2, right, 0.00000000000000062 in scientific notation. What numbers are not placeholders here? 6 and 2. Is 62 between 1 and 10? What could I do? 6.2. My A is 6.2. You don't get a choice in the times by 10. It's always times by 10. I'm going to have a red pen out. You can use whatever colors you want. Right now, in my A, where is the decimal point between? What numbers is the decimal point between in my A? 6 and 2. So right now, it's here in my thoughts. But where is it supposed to be? It's supposed to be here. So what direction am I jumping? To the left or to the right this time? To the left. And I'm going to jump 1, 2, 3, 4, 5, 6. No, it auto-corrected to straight. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 jumps. So what's my power of 10 going to be? Is it just going to be 14? Negative 14. Well done. Why? Because I jumped to the left. Can you get that example? Now see how you don't need to write all that other stuff at the top? The other stuff at the top was just to step through the thinking. But you told me the thinking this time. I've got one more example and then you've got the double lesson to practice this. If you finish early, the switch, but I'll show you the cheat sheet that I'll give as an example. Maybe don't start the practice test until Monday, okay? Well, you can have a look at it. You recorded a solutions video though on YouTube, but is anyone here subbed? You need to sub and ding that dong, huh? Get those notifications, yeah? You can see when I upload for all of my classes. Sorry, maybe don't sub because your feed is just going to be all Mr. It's just going to be Mr. Plaza constantly. Okay, one more example. We're going to do it back the other way. Is this one already in scientific notation here? You tell me. Yes, scientific notation or no? Yes. My A, this is my times by 10 and this is my power there. How do we go back the other way and write a decimal number? Well, just write this. 5, 7, 0, 6, 5, 2. I wrote it in the middle because I don't know which way I'm jumping. I don't know if I'm jumping left and right. Someone tell me, if I've got a power of negative 12, what direction am I going to jump? Left. I'm going to jump left. So right now, the decimal point in A is between 5 and 7. So I'm going to start here. And I'm going to jump left how many times according to you? 12. 12 times to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my decimal point will be there. I'll put a 0 to the left of it. What numbers am I going to put in all those little jump humps there? This is a really small number. What numbers are they going to be? Zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is how you go from scientific back to a decimal number. What direction would I have done the jumps if that was a positive 12? Right. I'd go right. Okay? So do you remember in that part, it's here on YouTube where I said, trust. Can you see where the trust come in? Jumping right, jumping left. I'll stop the recording now.